Okay, y'all. So I'm going to attempt to make a video covering some of the stuff that Dr. Geddon sent out in an email and we need to know for the midterm to help you all out. Okay, if I forget something, please let me know. I'm going to try to speak as slowly as possible. But, let's just get this train on the tracks here, boys and girls. Okay, ladies and gentlemen. So, for the following sequence, determine if it is linear, quadratic, or exponential. Then, write the recursive and explicit form to find all variables. Okay. Now, most of these problems I either took from what we did in class, the textbook, or stuff I have as from teaching Algebra 1. Okay, so from here, let's make a little table, okay, with our first term being 6, okay. So, oops, come on, that'll be a little bit difficult. So, a sub 1 is 6. Oops, sorry, negative 6. Oopsies. Oops. Okay, negative 6. Okay, so if I make my table, we have our a's and our, and our a sub n's. Okay. Now I'm not using Apple Pencil here or anything, so my handwriting is my handwriting. So just keep up with me here if you can. Pause if you need to. Okay, so our first term is negative 6. Our second term is negative 1. Our third term is positive 4, and our fourth term is 9. Okay. So what is the difference between negative 6 and 1? We have to add 5. Okay, from negative 1 to 4 we have to add 5, and from 4 to 9 we add 5. Now this here is called the common difference. Common difference. Okay, and this happens to be a first common difference because the first difference we found. And because it is the same or constant, we therefore can call this a linear function. Okay, so with linear, that's my answer. Okay, so if I'm going to write the recursive of this, we know that our first term is negative 6. Okay. And then to do our, typical from a sub n, that would just be the previous term, or n minus 1. Okay, n minus 1. Plus our common difference, in this case it's plus 5. Okay. Why can't poor handwriting, my poor students, plus 5. This here is my recursive formula. Okay. Now, I will say this. Okay, I did say to define the variables, but as you can tell, my handwriting is kind of woo. Okay, so my a sub 1 is my first term, and our a sub n minus 1 is the previous term. Okay. Now, if I want to write the explicit form of this, okay, that is what many of us know as slope-intercept form, which is y equals mx plus b, if you will. Okay, so if I always write that down, y equals mx plus b. M is our slope, which happens to be our first difference. Okay, now, to find our b, though, we need to go to the table we have over here and find out what 0 would be in the table. Okay, to do that, all we have to do is subtract 5 from negative 6, which would be negative 11. And as a result, our a sub n would be equal to 5n minus 11. Okay. Now, a couple quick things on that. First off, we write a of n, not a sub n, because it's not a function of n. Okay. That 5 in black represents my slope, which I got from the common difference in the table right here. And I got the negative 11 from backtracking from my table. Okay. Here's the next one. Now you may have seen this is a homework problem. Okay, I just happened to pull this bad boy right off the homework, which you've already got the answers to and everything, and I'm just going to work this bad boy out for us, okay? So for the following sequence, determine if it is linear, quadratic, or exponential. Then write the recursive and explicit forms, define all variables. So, this one's going to take a couple slides to do. Okay, now that we kind of know the direction, I'm going to slide this bad boy up a little bit. So if I'm going to create a table here, we have a and a sub n. Okay, that should be kind of your first go-to, so create the table. I'm just going to kind of, get over the directions, because you know what the directions are. Okay, a and a sub n. So, our first term we have 1. Our second term we have 5. Our third term we have 12. Our third is 22, and our fourth is 35. Okay? So, let's to determine if it's linear, quadratic, or exponential, we need to look at the differences. So, 1 to 5, we have to add 4. 5 to 12 would be what? Plus 7. Plus 7. Okay, 12 to 22 is 10, and then 22 to 35 is going to be 13. But whoa, those are not the same. Oh my goodness. Okay, so what do we have to do then? Let's look at the second difference now. Well, 4 to 7 is plus 3. 7 to 10 is plus 3. And 10 to 13 is plus 3. Oh my goodness. Those are the same. Aren't they the same? Okay, that is the common second difference now. Because the common second difference is the same, we can now call this a quadratic sequence. Okay? So, to write this now, recursive and explicit, I'm just going to create another slide real quick so I have the space to do that. Okay, so my recursive one now. Okay, now to write the recursive of a quadratic, we know our first term here was what, 1, I believe? Let me just check. It was. Okay, so now our a sub n then is going to be the previous term. Okay, plus, now what's the slope here? Okay, slope then would be 3, which is our second difference, plus 3n, plus some constant, or minus some constant even. Okay, so figure this out. Now, the easiest way I found is to, that we know a sub n equals a sub n minus 1 plus 3n plus some constant c. So that's like a sub 3, the third term in the sequence, which if you look at our table here would be 312. Okay, we know that this is going to be equal to a sub 3 minus 1 plus 3 times 3 plus c. From here to here, I just let n equal 3. That's all I did. Okay, so a sub 3 we know is 12, looking at the table on this page before, just right here. Okay, this here is going to be a sub 2, and a sub 2 is 5 plus 9 plus c. Now I'll just simplify that there. Okay, so here we get 12 equals, well, 5 plus 9 would be what, 14 plus c. And solving that one-step equation, we see that c equals negative 2. Okay, so as a result, it was a little preemptive of me to put that plus sign because it turns out, just so happens, that this is a negative 2. And that is my recursive formula for this particular quadratic. Okay, now, you thought that was fun. That's right, the explicit. Okay, so, if I go to write the explicit form of this bad boy, so now, this is the one where you have, you know, the 2a equals the first difference, right? So, this is, we did that big experiment with the table, and did the differences, and all that good dandy stuff, right? So here, our common difference was 3, so that's what I got 3 from. So solving this, we know that a equals 3 halves. Okay. Then we also know that 3a plus b is going to equal the first difference that we found in the table, which happens to be 4. So equals 4. So substituting what we know a to be, 3 times 3 halves plus b equals 4. Okay. Now, 3 times 3 halves would be 9 halves plus b equals 4. And we know that 9 halves is 4.5, so we subtract there, we're going to get negative 1 half. Okay, so far we know that a equals 3 halves, b equals negative 1 half. So now we got to find c, because we know the standard form of a quadratic is f of x equals ax squared plus bx plus c. Okay. This should look something like your tennis ball activity. We're going to click knowledge. Okay, so we know that a plus b plus c is equal to the first entry in the table, which is 1. Okay, so we can substitute our information here. 3 halves plus negative 1 half plus c equals 1. Simplifying the 3 halves minus the 1 half, that becomes 2 over 2, which is just 1, plus c equals 1, so c equals 0. So as a result, we can write our explicit form now, which is a sub n equals 3 halves n squared minus 1/2 n plus 0. You don't need to write the plus 0 part. Okay. For those of you with a graphing calculator, okay, you can always double check this. If you go to the graph and you type in 3/2 n squared, it's going to be x squared on my calculator because I'm doing a function of x, minus 1/2 x. Okay, type this bad boy in, enter it, and look at the table, and you should see that this table actually matches the one that we have originally started with. Okay. Got through 2 problems. Let's keep on going. Keep on chugging along, boys and girls. Okay. So, same directions now. For the following sequence, determine if it is linear, quadratic, or exponential. Then write the recursive and explicit form to define all variables. Okay. So, I'm going to create my table first. Okay. 1, -5. Oops, I'm sorry. Oops. Okay. It's actually 1, 1, 2, -5, 3, 25, and 4, -125. Okay. So let's look again. Look at the first difference. We know 1 to -5 is we're going to subtract 6. -5 to 25, we're going to add, what is that going to be? 30. And then here, it's a little bit more work. Oh, Lord have mercy. But okay. So that would be what, 25, -125, and so that's extensive mental math right now after a long day of hangout distance learning packets. So it'd be subtract 25 would be -150. Okay, so you can definitely see that does not match. So let's look at the second difference. Well, 6 to 30, -6 to +30 would be you're going to add 36, and you can definitely see the and 36 is not going to get you there, right? So that is not going to be linear, nor is it going to be quadratic. So now let's see if is it a geometric series. Well, 1 to -5 you can multiply by -5. -5 to 25 we can also multiply by -5. And 25 to -125 we can also multiply by -5. Okay? This here, because we're multiplying a constant, is going to be a geometric series, which is exponential. Okay? So if I want to be recursive this bad boy, we know a sub 1 is going to be 1. Okay? Or a sub n is going to be the previous term times the difference, or the ratio, if you will, is -5. You can write this a plethora of ways. You can also write it this way. If you like to have the coefficient first. Okay, this here in the green is your recursive. Okay, if I'm going to do my explicit, well, my explicit would be a as a function of n is equal to the initial term 1 times -5, which is my ratio, times to the n minus 1. Okay, this is my initial term. This is the difference between -5, and then let's put n sub 1 in the exponent. Okay, and that's it for that one. That one, the one that requires the most work, in my opinion, as you can see, is the quadratic one. Okay, so can you find the sum of the first 102 natural numbers? Can you use Gauss's formula? Why or why not? So we know the first 101 natural numbers will be 1, 2, 3, 4, all the way to 102. Okay? Now, let me see if I did. Okay. So, can we use Gauss's formula? Yes, you actually can. Okay, we start with 1, and we're going in sequential order. Okay, Dr. G posted the answer key to quiz 2 and all the homeworks, and she gave a really thorough explanation on that question on the quiz. Okay, so let's look at Gauss's formula then. It would be n plus 1 times n divided by 2. And you may say, but Mr. Ball, okay, why do we have to divide by 2? Well, that is because we are accounting for the sum twice. Okay, so here, if I just substitute this bad boy in, we have the first term and the last term. So 102 plus 1. Oopsies, hold on. 102 plus 1. Okay, now this plus 1 is just for Gauss because we start with 1. Okay, and how many terms do we have? We have 102 terms. I think I told you 102 numbers. Divide this bad boy by 2. So if I'm going to show all my work here, we have 103 times 102 divided by 2. Okay, and now I am going to go to the calculator here. Okay, and we will see 103 times 102 divided by 2 is 5253. So this means that this sum is 5253, or 5,253. And this problem is solved. Okay. Your problem very similar to the on the quiz, but I figure, you know, just throw another bad boy in there. It can't hurt, right? Okay. Now, I'm going to throw you a curveball, no pun intended. Okay. Find the sum of the following finite arithmetic sequence by finding the number of terms in it. So as you can see, we cannot use Gauss's formula here because our sequences now start with 1. So here we actually have to find the explicit form. Okay, if we go back to the first problem we solved, that was the one in slope-intercept form right there. Okay, so let's write this bad boy in slope-intercept form. Well, from 248 to 253, we need to add 5. Okay, 253 to 258, you add 5. 258 to 263, guess what? Add in 5. And that is our common difference right there. So even if I didn't tell you this is arithmetic, you should be able to tell me that it's linear by a common first difference. Okay? So we know that our a sub n, if you will, is going to be 5n, my slope, right? Plus some number. Okay? So what is that number going to be? Okay? Well, that's going to be the y-intercept. And if you remember how to find that bad boy, okay, you can just take away 5 from 248. So 248 minus 5 is going to be 243. Okay. Now, we have the explicit form. We need to figure out the number of terms in it. Okay. Dr. G said in her little message, okay, oh my gosh, computer, not the time to act up. Okay, oh my goodness. Okay, what is going on now? Not going to be able to go to it right now, but you understand, okay, that we need to be able to do this. So, we put the 2603 here, because this is the end of our sequence. Okay? Now, I'm trying to figure out, it says I'm recording here. Now, looking at this, we need to solve this for n, because n is the number of terms. So if I subtract 243 from both sides, okay, we get 2603 minus 243, 2360. Okay, 2360 equals 5n. Okay, and then we can divide both sides by 5 by using the division property of equality. We get n equals. So let's divide it. Oops, come on now. Here we go again with this thing. It wants to act out, doesn't it? Divide by 5, and we get 274. Okay, so there's this bad boy. Okay, we get 270. Is it 274 or 247? I can't remember now. Lord have mercy. 272. 472. Oh my goodness. N equals 472. So this is how many terms we now have in this sequence. Okay, so now to figure out the number, the sum of it, the sum, we would do the first term plus the last term times the number of terms. Okay, I'm going to call that n for this time being, divided by 2. So we know the first term was, don't remember, okay, 248 plus the 2603 times the number of terms we found to be 472 divided by 2. Now this, so you can put this bad boy right in the calculator, okay? So we get 248, yes, plus 2603, oops, mother of pearl, okay, 2603, good, divided by 2, oh shoot, sorry guys, I'm still all messed up here, let me restart this, okay? The 248 plus the 2603, multiply that now by the number of terms, which was 472, and divide that by 2, and that is your sum, 672, 836. Okay, I'm not going to remember that. Okay, 672, 836, 36. And that is your final answer. That is the sum here. Okay? Deep breath. Okay? I'm making it, guys. This video is probably going to be about 30 minutes or so. You can always rewind it, watch it again. Feel free to look at your notes, message me if you have any questions. Okay? Now, determine whether a number is divisible by all those by using divisibility tests. You will not be able to use a calculator or long division to answer these questions. So, let me just think of a number here. Let's pick a 5-digit number. Those are fun to work with. Let's go with 47264. Yeah, let's go with that one. Let's go with that one. Yeah. Okay. So, let's just go into it. Just to divide this number. 47264. Well, it does because the last digit is divisible by 2. Or does 3 divide this number? Okay. Well, let's just add these bad boys up. Okay. 4 plus 7 plus 2 plus 6 plus 4 is 23. Okay. So, this is not divide 47264 because 3 does not divide 23. Okay. Let's get 4. Does 4 divide this number? 47264. Okay. Well, yes, it does. Okay. If you don't believe me, let's just try this out. We have 47264 divided by 4, and you get a whole number. Okay, so boom. Good. Boom. Okay. Now, does 6 divide it? Well, 6 does not divide this number because 3 and 2 both need to divide it. Okay. 8 does not divide this number that I can think of off the top of my head because it does not divide 264. Okay. 264 divided by 8. Oh, missed the ball. I was wrong, guys. This is, like I said, it's been a long day, so actually it does divide it. Okay, that was not planned, but you know, monitor and adjust, right? I apologize. I really do. It does divide it because it does divide 264. And 10 does not divide it. I can tell you that one 100% sure now. Okay, because of the fact that this last digit is not a 0. Okay. It's a lot of fun here in these last 23 minutes. Okay. Determine whether the number is prime or composite. Determine if 109 is a prime number. So, what you need to do first, you need to take the square root of this number. Okay, but we know the square root of 100 is 10. So really, but you know, let's just be precise here, right? Take the square root of this number, 109. Okay, that does not help me, so I need to do Control Enter. It's about 10.4. Okay. So it's approximately 10.4. So now, that means we need to check all the primes less than 10, which would be 2, 3, 5, 7. Okay? Yeah. So we need to see if that goes into this 109 at all. If none of those go into it, then the number is prime. If it does, it is composite. So is 2 divisible? Is 109? Is 2 divided into 109? It does not. Using our rules from before. Does 3 divide 109? Well, 1 plus 0 plus 9 is 10, and 10 divided by 3 is not going to be a whole number. Let's try 5. Does 5 divide 109? It does not, because the last digit is not 0 or 5. So let's try 7 divided by 109. So this one, let's just go to the handy dandy calculator, and it does not, because you do not get a whole number back. Okay, so as a result, therefore, 109 is prime. Poor number, all alone. Aww. Okay. So, how I determined if it was prime or not? Well, what I did is I took the square root of it, and I looked at that approximation, and the prime number is less than that. I need to check the divisibility for. Okay. Less than 10 would be, the primes less than 10 are 2, 3, 5, and 7. So we check all 4 of those. Because they all failed the divisibility test, the number is prime. Okay. Now, find the sum of a finite geometric sequence. Middle school and high school teachers, you need to be able to prove this rule from what I can remember Dr. G saying in class. Okay? I will do that at the very end so that way I don't have to bore the elementary teachers with that. Okay? Now, allow the sequence below to represent the amount of citizens infected with the coronavirus. what is the total amount of sum of people affected after 20 days? Now, I kind of came up with this, kind of make it a little bit more real life instead of just giving you a bunch of numbers. So, we know. Well, first of all, we need to figure out what is our rate. Okay, well, from 2 to 10, we multiply by 5. 10 to 50, multiply by 5. 50 to 250, multiply by 5. So my rate is 5. Okay, and what is my first term? Is 2. Okay, for this sake, I'm just going to substitute it into the formula to show you how to do that. Okay, so we know that the sum of the sequence is going to be the first term times this term here, 5. Okay, not the rate. Okay, to the 20th power, all subtracted 1, divided by 5 minus 1. Okay, this is just the formula, because now, for those of you who don't remember the formula, S sub n equals a times r to the n minus 1 all over r minus 1. So in our example, our a is the first term, and our rate is 5, and our n is 20, because I used 20 days. Okay, now this one is going to be ginormous. Okay, so go to our calculators. Okay, we have 2 times 5 raised to the 20, all subtract 1, divided by 5 minus 1 is 4. So that is the number of people affected by the coronavirus. Now, just for the sake of, completeness, okay, I don't know if it's going to let me because I'm screen recording. It's not going to let me. Oh, man. Okay. Number, which I'm going to try to remember to write down, is the answer to this problem. Okay, that means that after 20 days, that many people are affected or infected, I guess you could say, with the coronavirus in our example. Okay, day 1 started at 2 people. Day 20, it is at that. Okay, you can see how exponentially it is actually growing. Quite rapidly. Okay, quite rapidly. Yowzers. Okay, I can even fit that on the slide if I wanted to. Okay, now this here is just like the tennis ball activity. Okay, I just took a graph I use in my notes when I teach this to my freshmen. Okay, I'm just going to go through and answer these questions now. So part A, is A positive or negative? Okay, well, if A is positive, we have like a happy face looking shape. If A is negative, it's a sad face. Looking at this, you can see it's kind of a happy face. So our A, okay, so I'm just going to erase that now that I said it, so I create some space here. Our A is going to be positive, and how do we know? Okay, because we actually have a minimum as our vertex, and it's a happy face. Okay, I don't think Dr. G's going to accept that it's a happy face, but for you, your ability to see what it is, I think that'll help you remember. Okay, determine whether the zeros are negative or positive or neither. Well, the zeros have many different names. They are also called the roots, the solutions, and more commonly used in algebra, the x-intercepts. Okay, so x equals the point where which this graph crosses the x-axis, which should be at 2 and at 4. Okay, it is very clear here that these are both positive numbers. Okay, now if you look at my example that my group did on the tennis ball activity, our parabola actually does not touch the x-axis, which means there are no zeros, and it also means that the quadratic of this form is prime and not factorable. Okay, part C, identify the vertex. Okay, the vertex is going to be the highest or lowest point on this graph. Okay, because of the fact that our graph, this parabola right here, is a positive, which means it has a minimum point. This is a definitive minimum point right there. What is the coordinates of that point? That would be the coordinates 3, comma, -1. Okay, that's this minimum point right there. Okay. Part D, I've already answered. It has a minimum in our graph. Okay, you can tell that this graph doesn't get any lower. Groups like apple, bottom, gene. Okay, this cannot go any lower than it possibly is at this point. Okay, and the axis of symmetry. Now that there's a formula for that, but she's not going to give us the function. She'll give us the graph. So the axis of symmetry. Okay, it was if I was to draw a line down the vertex right there. Okay, if I was to take that line and I was to fold the parabola over that line, it completely overlap. Okay, so we're using that. What is the equation of this line, this green line that I just drew? Well, it would be x equals 3. Okay, and that is answer to part E. Okay, the line of symmetry. Okay, again, if you have any questions, please do email me. Okay, now I put this functions in out here. because I'm not sure if she's going to put the stuff that we did in the last class on functions on this midterm. It did not look like it from the PDF she sent us, so it might be a question I send her an email and ask her. But if she didn't put it on there, on the PDF, I don't think she's going to put it on the semester exam. Now, while I have you here, my email, if you have any questions, is rball@hcpsd.net. Feel free to shoot me an email. I'm quarantined, distance learning over here, so just me, myself, and I here. Okay? Now, for those of you that are elementary, that do not need to prove the sum of a geometric sequence formula, you can stop the video now. The middle and high, which I think we need to, I'm about to do that right here, so it's all in one place. Okay? So take some sequence, right? Oops, come on, don't be scared now. Some sequence of n, right? Okay? That's going to equal a, comma, a, I'm sorry, not comma, oopsie, some sequence of equals a plus a times r plus ar squared all the way down to a to the n minus 1. Okay? Good. Okay? Now, take this whole thing and multiply by the ratio. Just for, giggles. Right? So that means that our first term now becomes a sub r. Our second term becomes a sub r squared. And then a sub r cubed. All the way down to a plus a sub r. Okay? Okay, if I was to do a sidebar to explain that to you really quickly. Okay, the last term in the blue was a sub r to the n minus 1, right? I can rewrite this as a sub r to the n times r to the negative 1 by my rules of exponents. If I was to take this whole thing now, like I was doing the second line, and multiply by my ratio, I get r to the first times a times r to the n times r to the negative 1. By the associative property, I can rewrite this as a times r to the n times r to the 1 times r to the negative 1. Okay? By rules of exponents, I can add these two together to get r to the 0. Anything to 0 is 1. This whole thing just becomes a times r to the n. Okay? Now that I have these two here, let me line them up and just add these puppies together. So, if I write this here, I have this first one, right? If I subtract s sub n, right? Well, that's a plus a sub r plus a sub r squared plus a sub r cubed plus a sub r to the n minus 1. Okay, I just put the blue into green now. Looking at this, I think we can all agree that a sub r is going to be bigger or larger than a sub r minus 1, this term right here. Why? Because this has the previous term where this would be the finite term. Okay, if I subtract this, what do I get? Well, this cancels, and this cancels, and this cancels. And then somewhere in here, we'll cancel that. Right? Okay, so when I do this, I get a sub r, well, r sub n minus s sub n equals a sub r, oops, not a sub, I'm sorry, ar minus a. Right? I think that's right. Okay, actually I know that's right. Okay. Now if I look at the left hand side, there is a comment. I'm going to rewrite this on a new slide now because it's getting kind of whoopies. So we have r times s sub n minus s sub n equals ar minus a. Okay? Remember, I need to write this whole video. Okay? Look at that. On the left hand side, they have a common term. They have the s sub n, right? So I can actually factor that out. And what's left over is r minus 1. On the right side, they both have an a in there, so I can factor that out, and I get r minus 1. Oops. Mr. B made a mistake. There should be an n there. Sorry, which I proved to you on the slide, so I just copied it over. Okay? Looking here, I want to find the sum, which is s sub n is the sum. So to get that, I need to divide by r minus 1 on both sides. So therefore, s sub n equals a times r minus 1. Okay? And it should be definitive that r cannot equal 1. Okay? Because then the denominator will be 0. And that is your proof of that formula. Okay?